We discussed the types of collision. We need to know the meaning of coefficient of restitution. The dictionary meaning of restitution is regaining. You take an example of collision of the ball with the ground. The ground is stationary. The ball collides with the ground with a velocity of say 10 meters per second. It is falling down. It is coming down. So the velocity of the ball with respect to ground is 10 meters per second in downward direction. But just after collision, the ball will move up. So with respect to ground, the same ball which was moving down just before the collision will move up just after the collision. In other words, we can say that the ball departs. The ball was approaching just before the collision. With what velocity the ball was approaching? 10. Just after the collision, the ball will go up. It will get separated. It will separate from the ground. With what velocity? That is obviously less than 10, because part of the energy will be lost in the form of heat, light and sound. If we assume that the ball will separate from the ground with a velocity of 8 meters per second, the velocity of separation can be equal to 8. And the velocity of approach, the ball was approaching the ground just before the collision with the velocity 10 meters per second. Therefore, we can write the velocity of approach is 10 in negative y direction or downward. This is a scenario just before the collision. Just after the collision, the ball say move up with a speed of 8 meters per second. It is up means positive jacob or positive y direction. This velocity with which the ball separates or departs from the ground is called velocity of separation. If you compare these two velocities, velocity of separation is always opposite to the velocity of approach, and velocity of separation is always lesser than the velocity of approach. Velocity of separation is negative of the velocity of approach. It is separating, it is approaching. It is approaching, it will be separating. So these two velocities must be opposite. And velocity of separation is always less than the velocity of approach. Or we can say that the velocity of separation is a fraction of the velocity of approach, and that fraction is called the coefficient of restitution. A is the coefficient of restitution. In this case, A is equal to velocity of separation, its magnitude, upon velocity of approach, its magnitude. The separation velocity is 8 meters per second and approach velocity is 10 meters per second. So we can just write coefficient of restitution for this example is equal to 0.8. Answer. 80% of the initial velocity is restituted or restored. 80% or 0.8 fraction of the original relative velocity along which line? Along the line of action. Along the line of action is restored or restituted. So what is coefficient of restitution? The fraction of the relative velocity between the colliding objects along the line of impact. That is velocity of approach, the fraction of the relative velocity between the colliding objects, or you can say initial, just before the collision. The fraction of the initial relative velocity between the colliding object. This is the initial relative velocity. Velocity of approach is nothing but relative velocity between the colliding bodies along the line of impact. That's the U relative. And separation velocity is V relative. The fraction of the initial relative velocity between the colliding objects along the line of impact, that is velocity of approach. Restored or restituted just after the collision is called coefficient of restitution. So it is the portion or the fraction of the initial relative velocity between the colliding objects taken along the line of impact, that is the velocity of approach. What fraction of the velocity of approach is regained or restituted or restored just after the collision or impact is called coefficient of restitution. So this is an example of head-on collision. If the colliding object has velocity 10 meters per second just before the collision, just after the collision, say it bounces back with a velocity of 8 meters per second. So this is the approach velocity, this is the separation velocity. You will take the ratio of separation and approach, you are getting a fraction, that is the coefficient of restitution. Let us take another example. Let the ground move up with the velocity u1 is equal to 2 meters per second up. Let the ball move with the velocity u1 is equal to suppose 3 meters per second down. This is the scenario just before the collision. If the surface of the ground keeps on moving with same velocity. Assuming coefficient of restitution is equal to 0.75, find the velocity of the ball just after the collision. We have this formula, velocity of approach into the coefficient of restitution, negative of that is equal to velocity of separation. This formula is known as the Newton's empirical formula. Newton's empirical formula. Approach velocity is nothing but the relative velocity between the colliding objects along the line of collision. Along the line of collision. Just after the collision, let the ball move with velocity v, and the ground keeps on moving with same velocity. The velocity of the ground remains the same, that is 2 meters per second up. Let the velocity of the ball just after the collision vv. Now velocity of approach we can calculate. Approach velocity is equal to velocity of 1 with respect to 2, initial velocity. So I can write u. U stands for initial, v stands for final, or you can write ui or vi or vf. If you take this is 1, this is 2. If you take this is 1, this is 2. What is u1? Minus 3 jkf, because it is moving down. What is u2? It was moving with which velocity? With what velocity it is moving? To upward direction. So you are getting the approach velocity minus 5 jkf. Let us find the separation velocity. Velocity of separation is equal to, this is 1, this is 2. You cannot change the order. You cannot change the numbering. V1 minus V2. Along the line of impact, of course, this is central collision or this head-on collision. So line of impact and line of motion both are same line. V1 minus V2. What is V1? Let it be V. Let it be V. And we have assumed it is of V jkf. What is the velocity of the second object? That is 2 jkf. So you can get V minus 2 jkf meter per second. This is equation number 2. Apply Newton's empirical formula, or minus A into velocity of approach is equal to velocity of separation. Minus sign should be there, which signifies that the approach velocity and separation velocities are oppositely directed. Value of coefficient of restitution is given 0.75. Approach velocity you are getting minus 5. The separation velocity you are getting v minus 2 from equation number 2. So substituting the value of the approach and separation velocity in the Newton's empirical formula, we can get this step. And after this, directly we can get the result after little evaluation. So it will be minus into minus plus, 5 into 5, 25, 3.75. The left hand side will be 3.75 and the right hand side will be v minus 2. So we are getting v equal to 5.75 meter per second. Ball will move with a velocity of 5.75 in upward direction just after the collision. So these are some problems we are discussing to understand what is coefficient of restitution and how it is defined by an equation which is called, or a formula which is called, Newton's empirical formula. Because this rule, this formula had been derived empirically or practically. Let us take another example. Let the ball move towards right with a velocity v naught, and this wall, which is very massive, keeps on moving with a velocity u. Is the coefficient of restitution of the collision between these two objects. Since the wall keeps on moving with the same velocity, just after the collision also, its velocity will be equal to u. Or you can assume that no friction is there between the wall and the ground, or ground is smooth and the wall, its mass is much greater than the mass of the ball. When the ball collides under the condition that u must be greater than v naught, then only collision takes place. When u is greater than v naught, you can, if you are glued with the wall, you can say that the ball is approaching with a velocity, how much? U minus v. Just after the collision, let the ball move with velocity v, and we have to calculate that. Find the velocity of the ball. Just after the collision, assuming coefficient of restitution is E. It's a qualitative problem. Either you push it with a constant velocity, or you assume that this is very large compared to the mass of the ball. So during the collision, its momentum will not change significantly. It is just like when you are moving, a mosquito comes and hit you, and you don't find practically any change of your speed and the direction of your velocity. So when this ball, which is very light compared to the wall, collides, the velocity of the wall will never change practically. Therefore, wall velocity can be assumed constant. If it is not given that the wall is moved with constant velocity, under these assumptions you can assume that the velocity of the wall does not change too much or significantly. When you assume the speed of the ball just after the collision as v, wall velocity remain unchanged. We can apply Newton's empirical formula, which states that minus of a into approach velocity is equal to velocity of separation. We call it 1 and call the wall 2. We call this 1, call the wall 2. This is x direction. Velocities along x direction can be taken positive or plus I cap. the velocities along negative x direction can be taken minus or minus I cap. Minus A. What is the approach velocity? u1 minus u2. What is separation velocity? v1 minus v2. The standard notation I am following. Minus E. What is u1? Plus v naught I cap. Write vectorially. What is u2? Plus u I cap. What is v1? We assumed it as v in positive x direction. What is v2? This is still u I cap. Next step, you are getting the answer. V is equal to u into 1 plus A minus A into V naught. Answer. And they will give you specific values, just you can evaluate. So these are the types of problem you can get. Sometimes they can ask you a bit twisted question. In this particular case, there is a chance that this ball will fall dead. You can write the next bit. If the ball falls dead, means the velocity will be equal to 0 just after the collision or impact. Find the coefficient of restitution. We have to expedite this step, extend this step by putting v equal to 0. We are having u into 1 plus A is equal to A into V naught. Therefore, A into V naught minus U will be equal to U. And this gives us E equal to U by V naught minus U. Now question arises, can U be greater than V naught? When U is greater than V naught, the entire thing will be negative, and the value of the coefficient of restitution cannot be negative. Therefore, V naught should be greater than U. V naught is the speed of the ball, U is the speed of the ball, and when the ball moves faster than the ball, the collision will never take place. The collision will never take place. When you just believe in the mathematics blindly, you will be in trouble. The question I imposed, if the ball falls dead just after the impact, find E. You will be having 4 options. You can have this option also. The students who blindly believe in this mathematics, by putting V equal to 0, you are getting this term. U into 1 plus A is equal to E into V naught. So if you take E common, you are getting V naught minus U, that's equal to U. So you are getting this term is always less than 0 because V naught is less than U. So U is greater than V naught. Therefore, this becomes negative, which is discarded. Physically, this situation will never arise. So the ball cannot fall dead just after the impact. in this case. So this is a small example to assess the situation and getting different result, to directly follow the mathematics to get different result. So in physics, you have to verify the mathematical result whether it is physically possible or not. Now we will discuss the next important concept, the conservation of linear momentum. In last chapter of the system of particle, we discussed this idea. Here I will recast this idea very short form, because the collision between these two objects is a clear-cut case of system of particles. Whenever no force acts from outside on a system of particle, or net external force acting on the system of particle will be 0, we can conserve the linear momentum of the system of particle. That is what we know as conservation of linear momentum. That idea can be applied during the collision. And when the particles collide, every attempt will be made to ensure whether any system, either it may be of one particle or taking each colliding particle as a system, or taking the entire colliding particles as a system, we need to assess, to examine, to introspect whether we can conserve the linear momentum of the system or not. That is what we are going to discuss now.